So now I need to go back in the opposite direction now that I have this split up. So I'm going to do the inverse Laplace of each of these terms. The f of s just becomes f of t. I'm back into that variable. And then I have 1/9. And then when we have the s minus a on the bottom, we get e to the 5t. And then we have 17/9 e to the negative 14. For your second problem, t plus 1 cubed, what you have to do is multiply this thing out, and then you're going to take the Laplace of each term. So I tend to, you can do the binomial theorem if you want to, but I usually just square it and then multiply it out, the other factor. So t plus 1 squared is t squared plus 2t plus 1. And then we still have another factor of t plus 1. So FOIL that out. I get t cubed plus 2t squared plus t when I multiply the t by each of these. And then when you multiply the 1, we get t squared plus 2t plus 1. Combine like terms, I get t cubed plus 3t squared plus 3t plus 1. Right, so that's how I have to rewrite this. Plus 3t squared plus 3t plus 1. And now I can Laplace each term. So the t cubed becomes 3 factorial over s to the 4th, and then 3 times 2 factorial over s cubed, and then 3 times 1 over s squared plus 1 over s. Sorry, it's kind of running together. And I think I have to look that problem back up. I just wrote it down. I think that's what they wanted you to do for that one, is just to Laplace each term. But I'm pulling it up. I don't know if that one was an inverse Laplace or not. No, they just wanted you to Laplace each term. So that's what you would end up with.